Hello everyone, my name is Chunxu Liu from Nanjing University. In this video, I will introduce our recent work, Sparse Global Matching for Video Frame Interpolation with Large Motion. We propose a new pipeline for VFI, which can effectively integrate global-level information to alleviate issues associated with large motion. Specifically, we first estimate a pair of initial intermediate flows using a high-resolution feature map for extracting local details. Then, we incorporate a sparse global matching branch to compensate for flow estimation, which consists of identifying flaws in initial flows and generating sparse flow compensation with a global receptive field. Finally, we adaptively merge the initial flow estimation with global flow compensation, yielding a more accurate intermediate flow. To evaluate the effectiveness of our method in handling large motion, we carefully curate a more challenging subset from commonly used benchmarks. Our method demonstrates the state-of-the-art performance on these VFI subsets with large motion. Our method begins with the observation of large motion challenges, where the correspondence of objects between frames is hard to locate due to the large pixel shifting. Previous works either fall short at balancing the performance between large and small motion, or limited in computation resources to handle large resolution inputs. In our work, we establish sparse global correspondences between input frames using a global receptive field and takes a two-step strategy to compensate for the intermediate flow estimation. To be more specific, our method begins with an initial estimation of a pair of intermediate flows using a relatively high-resolution feature map. Following this initial estimation, our approach incorporates a sparse global matching branch to locate potential error in the flow estimation results, and then produce flow compensation to provide an effective remedy for capturing large motion. In our sparse global matching branch, we build a difference map to pinpoint the flaws in initial intermediate flow estimations. Concentrating on these defective areas, our approach employs sparse global matching to establish global correspondences between two adjacent input frames, specifically at these sparsely targeted locations. Subsequently, we convert this bidirectional sparse flow correspondence into intermediate flow compensation. Finally, we employ a flow merging block to adaptively merge the initial intermediate flows and flow compensation, thereby effectively combining the local details with the global correlation. In order to benchmark the effectiveness of our sparse global matching module on handling large motion, we carefully analyze motion magnitude and sufficiency within existing benchmarks. In our analysis, we utilize the motion sufficiency filtering method in previous work, emphasizing the minimum of the top 5% of each pixel's flow magnitude as the key indicator of large motion sufficiency. In the end, we carefully curate the most challenging subsets for large motion evaluation. As a result, in such challenging evaluation conditions, our proposed method demonstrates a substantial improvement in terms of PSNR, enhancing it by 0.66 dB while correcting half of the points in initial flow estimation on X-Text 4K. Furthermore, even with the correction of just 1/8 points, we still observe a notable increase of 0.48 dB. As shown in figure, our approach achieves state-of-the-art performance on almost all test sets. Besides, we observe that our results remain consistent with those in small to medium scenarios, and they are comparable to a SOTA algorithm VFI former on these benchmarks. This suggests that our local feature branch already achieves satisfactory results, and introducing our sparse global matching branch has a limited negative impact on the overall performance. In this paper, we have presented a sparse global matching algorithm designed to effectively address the challenges posed by large motion in video frame interpolation. We establish a framework that extracts local features for intermediate flow estimation Then we target the flaws in the initial flow estimation and perform sparse global matching to produce sparse flow compensation across a global receptive field. By adaptively merging initial intermediate flow estimation with sparse global matching flow compensation, we achieve state-of-the-art performance on the most challenging subset of commonly used large motion datasets while keeping the performance on small to medium motion benchmark.